Wireless LAN Professionals Podcast, episode 177.
5G and Wi-Fi technologies, the way, obviously, people have different opinions, but my opinion is that they are not going to be really challenging to one another. To me, they look more like a complementary technologies.
Wireless LAN Professionals is a place to educate, inform, encourage, and entertain those involved in wireless LANs. This Wireless LAN Professionals podcast is an audio manifestation of these goals. Our host is a wireless LAN veteran, consultant, designer, and teacher, Keith Parsons. And now, the podcast for wireless LAN professionals by wireless LAN professionals.
Well, Keith, how are you, sir?
Doing very well. Sounds like it's time for another question and answer period.
Absolutely, yeah. So we got some more questions coming in. This one comes from Bob, and he says, my biggest WLAN challenge, getting non-technical people to have a basic understanding of the dynamics of wireless environments, how the WLAN changes due to changes in the RF second by second, to not assume that just because you might be close to the access point does not mean you're associated to the access point. Placing of access points by utilizing proper tools is the only way to deploy a WLAN. Walking through with the floor plan and putting red X's where you think the access point should be is not a good scenario. How would you respond to that?
Well, first, there's actually a couple of questions in there. I'll tackle them each one at a time. The first had to do with getting non-technical people to understand how dynamic wireless is. First, the wireless has been designed from the very beginning, 20-something years ago, to be very, very robust, which is a fantastic thing. It means it will stay connected and be able to send traffic in spite of all sorts of things that might be going on around it. And it does that by downgrading its throughput, which is why, when people say the network's down, but when they get to Wi-Fi, they say, well, the Wi-Fi's slow. And the reason it's slow is because it's been programmed to go slow. That's what it's designed to do. And so, yes, there's a whole bunch of dynamic things going on, and it takes, a minimum of a half hour, maybe to a couple of hours to explain the complexities of how Wi-Fi works. So when you meet up with, non-technical people, it's pretty hard to get them to get a grasp on how unique Wi-Fi is in the networking world. And, if I have some time, I might attempt that. If not, we just, kind of scoot over that and start on the design process. So sharing it with them is, just let them know that was the goal of Wi-Fi, was to slow down when it's having a difficult time. So if your Wi-Fi is slow, we can help figure that out. The second part of the question was, had more to do with, you need to have proper tools in order to do a design. And I'd kind of disagree a little bit with that. Now, I'm 100% behind getting the most professional and best tool to do the job as you can. But back to the very beginning, when I said Wi-Fi is, from the very beginning, designed to be super robust, if you do it wrong, it still works. If you break all of the rules, you put an AP on the wall like a clock instead of hanging it the way you're supposed to, you tuck it behind some metal grid, it still works. Wi-Fi is just so incredibly robust of a protocol that when you break the rules, it continues to work. Now, it just doesn't work very efficiently. So if you design wrong and you don't use the tools, when you're done, you'll have Wi-Fi that works. We've all been to hotels that have Wi-Fi going down the halls, channel 1, channel 2, channel 3, channel 4. And yet it still works. Realizing that today the slowest you can get Wi-Fi in G or N mode is 6 meg. And you only need 2 meg to get SD Netflix, maybe 4 meg for HD Netflix. So even the worst performing Wi-Fi will still be able to deliver Netflix to customers. The question is, what's the most efficient way of designing Wi-Fi? So I'm going back maybe 18, 19 years. I used to put red X's on maps. That's how we designed. That's what we thought. Well, what was mattered was how far does the coverage of an AP go. You'd stick up an AP, you'd walk to the edge, put a little mark on the paper, and move on and repeat and repeat, repeat. So you can do what Bob said you couldn't do. It actually works. It's just not very efficient. So I think what we need to focus more on is how do we get Wi-Fi that works as efficiently and meets all the requirements, not merely coverage. We need primary coverage, secondary coverage, co-channel interference has to be designed out of our networks. And that doesn't happen with just using the red X method.
Not to speak for Bob, but I also wonder if I'm hearing any frustration in his question here as well, of like, I don't know if he's talking about those higher up in the chain. What do you call those, layer 8, or just regular customers? And how do you kind of deal with that when maybe those making the decisions or paying the bills, or your customers, when they're just not getting it?
Well, that does happen a lot of times. One of the techniques that I've kind of proud of, and I've done it a lot with a lot of different companies. And I'll just happen to use a hospital as a sample environment. When a nurse says, "Oh yeah, the Wi-Fi is bad. We drop signals always right here. There's a dead zone right there." And first of all, in the last 15 years, I don't think I've found a dead zone in Wi-Fi anywhere in the world. There's always Wi-Fi. It's whether or not it does what the people expect it to do. So I meet with the nurse and I say, "Okay, we're going to go figure this out. But it's going to take some time here. Let's what kind of music do you like?" And I find the music they like. I put on my iPhone on Spotify, and I'm on the wireless network, and start walking to find this bad place. And as we're walking down to find the bad place, the music's playing in the background, and I'm talking and chatting away with the nurse. And we get there, and she goes, "See, look at it." And her computer forced her to put in her password again. And so she says, "See, this is the bad place." And while we're standing in the bad place, we're still listening to Spotify's coming in quite nicely. And so I say something like, my battery's out. Can you get your phone on Spotify? And so they whip out their phone, they connect up, they're playing the music. And I switch up and I have my phone ping their computer that's supposedly in the bad place. And I can show them that Wi-Fi is working.
Yeah.
Their Spotify is working. My Spotify was working. Their laptop is taking a ping back from my phone. My phone's actually sending the signal up to an AP. It's going back to the switch, coming back from the switch to the AP, and going down to her phone. And I kind of explain what a ping is. And then if you wait just a couple seconds and give them some time to think about it, they go, "Wait, my phone's playing music right here."
Yeah.
And then they ask the question they should have asked originally was, "Well, if the Wi-Fi is going here, then how come my laptop made me put my password in again?" And when we get to the right question, then we're like, "Well, that's a really good question. Now, why did your laptop make you put your password again?" And you can see it wasn't because the Wi-Fi dropped. It's because something else was going on. So I like to find some scenario where we can talk about Wi-Fi separate and keep it away from what they thought it was. There's a lot of things that can go bad with networks. You can have bad DNS. You can have a bad DHCP. You can run out of DHCP scope. You can have an app that logs you out. In this case, it was the app logged them out at the exact number of seconds from when they signed in at the nurse's station until they walked down and turned the corner. Then it made them log back in again. Had they walked a different way, that would happen someplace else. But this nurse always started her shift, signed in, then walked down to the corner to get to her station, and it dropped always in the same spot. So it's find the thing that can show is Wi-Fi really working or not. Another technique that works really well is to be able to, I like using Adrian Granados's tool and be able to show on the screen what the current connection rate is, what's being offered from the AP, what I might happen to be on a Mac, what my Mac is going to send the next frame at, and then run a speed test. And you can see there's a huge difference between what I'm connected at and what the speed test is, and have the users realize I'm doing really good up to the Wi-Fi, but my connection to the internet is slow. One really cool thing we do is we have on the WLAN Pro's store something called a WLAN Pi. And you can put this little computer on the switch, the same switch that your access point's on, and then hit its web page and run a speed test. And now we're not speed testing out to the internet. We're only speed testing from wireless and only one wired link back to the WLAN Pi. And then show them on your own machine, hit the WLAN Pi and you run a speed test. It's just an HTML5 page. And then run the same speed test against an internet connection. And now when you compare the two, you'll see what's going over the wireless versus what's going over the wired. And many times, if we're getting a fast, MCS 7, 8, or 9, we've got fantastic Wi-Fi. Unless you're down in the sub 5 MCS, the RF's doing really, really well. And so to be able to show them and break apart for your customer, where is it a wireless versus a wired issue? Now, as network professionals, we still have to fix the problem. We want to troubleshoot down a little bit. I really like it when I can get my customers to make those calls for me. That after I've been there and I've been with the nurses or the office managers, whoever had the initial complaint, the next time, okay, maybe not the next time, but through the third or fourth time they call, when they call in, they say something like, the Wi-Fi is really good here because my Spotify works, but this other thing happened. And get them to start thinking where those breaks are.
I love that, the Spotify test.
Well, I one more example that actually fits in this the same. Let's say you were a big cable company and you're putting in cable modems in everyone's houses. And when they call in and they say, oh man, the internet's terrible, it's your cable modem that caused the problem. And they call in the tech support, and the tech support says something like, will you please go to your cable modem and unplug it from the wall and wait 10 seconds and plug it back in again. The whole reboot test. Now, if you're a cable technician and you told a customer to do that, and when they're done, it starts working, you've just reinforced in their mind it was the cable company's problem because when we power cycled the cable modem, that fixed it. So obviously the cable modem was broken. Same exact scenario. Someone calls in, I think my internet's bad, and the technician on the end of the line says, oh, could you try this for a minute? Could you go into airplane mode on your phone and then turn it on and turn it off, which basically means it's going to let go of Wi-Fi and join Wi-Fi a second time. And now if that fixes the problem, and it should, a lot of the times the Wi-Fi issues are just you're associated with the wrong AP, you're in the wrong position, something. But by doing a airplane mode on and off again, it resets your phone to join the correct AP. And if that solved the problem, you've just trained your customer to think, oh, it's my phone that was the issue, not the cable modem. And then now I can fix it myself in the future. All I have to do is do this little, release and renew of the Wi-Fi. And if that fixes it, then I'm good to go. And so there's some things you can do to help your customers do their first layer one troubleshooting all by themselves.
WLAN interview. Getting to know the leaders, movers, and shakers in the wireless LAN world.
Welcome back. This is Keith Parsons with Wireless LAN Professionals. And today I'm with Jari, see if I even got close to hitting that correctly, from ETS Lindgren, and wanted to talk today a little bit about some interactions between 5G and Wi-Fi and some ways we can look at doing some testing for that. So how are you today, Jari?
I'm doing great. Thank you. Thank you, Keith, for inviting us for this session.
Well, how about if you introduce yourself and say your last name so I don't have to?
Well, my name is Jari Vikstedt, and like you said, I work for ETS Lindgren. I've been here over 20 years, and ETS Lindgren is a test and measurement solution provider for wireless industry and other industries as well. But since we're talking about the 5G and the wireless LAN, it's one of the main industries that we're involved with.
Just tell me, how do you test wireless? What's kind of the general process?
So there are several different ways you can test wireless. So when we talk about wireless testing, we typically talk about over-the-air testing. So a lot of the industry before 5G has been doing wireless testing also conducted mode. So basically all the conformance type of testing has been done in conducted mode, where the cable is connected to the device instead of going through the antenna and over the air. Now with industry moving higher in the frequency range and the chipsets are getting very tightly packaged and integrated with the antenna array elements, this is no longer possible. So most of the industry is moving towards over-the-air type of test methodologies where you need to have a controlled environment where you're performing your testing, whatever the testing is, whether it's a radiated power or sensitivity type of testing, and now moving more in the adaptive smart antenna environment. We also need to be able to understand and control where the energy is going or where it doesn't go. So we try to filter the interference sources out so that we can help the links to provide best possible signal to noise ratio or data throughput, whichever metric you are planning on testing.
Well, let's go in a way back machine here, then just slightly back to wired-based testing. Why would some vendor who wanted to test their equipment choose to use a connected link where they just uncouple the antenna and connect the wire from one transmitter directly to the receiver? What would be the purpose? Where's the win there? It feels so not real.
Well, that is correct. So a lot of the conducted testing where we connected directly to with the cable to the test device, those were more or less what we call the conformance parametrics that we were measuring. Basically, we were trying to understand how pure is the modulation that the chipset and the device is producing. We're trying to understand, spurious emissions, because we can understand how much spurious emission is coming already from the device, even without that connecting to the antenna. And it was perfectly fine way of doing the conformance, basically the mandatory requirements that FCC and 3GPP and standards organizations are requiring. But immediately when that is no longer possible, you need to do that over the air. So when we move into the performance metrics, so there's a clear distinction between the conformance and performance metrics, even when you were able to connect to the device directly, is that when you including the antenna as part of your chain that you're trying to measure, you're moving more towards the performance metrics. So you start understanding where is the energy actually going. So previously with the conducted testing, if you're trying to measure the power that it's generated by your PA, you understanding that yes, there's a power coming. But when you actually implementing or connecting that to the antenna, now you have different set of expectation. You kind of understand where the energy is going, and that's very critical when you're designing any kind of wireless network, whether it's a wireless LAN or the future 5G network, that you kind of understanding where the energy going so that you don't waste the energy and the resources.
So again, still just a little bit back in history, I could see when you were running 8 or 11 G or N. Well, not even N, when you just had G, when you could use conducted. But as soon as you needed to see Mimo, how do you, with a conducted test, find out whether or not there's actual spatial streams available in your environment? When you use a conductor, you took away all of that, the whole spatial stream.
That is correct. I mean, there is a possibility because you're still running the streams to a different antenna elements. You can see that there's a traffic on different antenna ports, so to speak, but it doesn't really tell you how well the spatial streams are going to be conducted or connected to the device that you're trying to measure. So Wi-Fi access points or wireless LAN access points, they are relatively easy on our point of view to have a good MIMO performance, because you need to have a spatial difference between the antennas, and you are not really limited on the size. I mean, yes, there is a typical sizes on wireless access points that you need to stay under so that they are not too bulky. But when you compare that to like a handset that you are communicating to, you have a typical size that the handset can be, and it's a lot more difficult to have the spatial streams connected to a handset where the antennas are a lot close proximity to one another, where, like you mentioned on the wireless access point, you have the spatial separation between different antennas, and therefore it's easier to actually do the uncorrelated signals that are creating the separate spatial streams.
Then moving into the future, well, we're kind of there now. Is it a requirement to use over the air if you're going to try to test multi-user MIMO?
It actually comes a little bit that because it's once again the multi-user MIMO starts to be more performance-driven metric. So with the multi-user MIMO, you're trying to have obviously multiple streams to multiple users, and you cannot really do a lot of separation or even detection on multi-user MIMO in a conducted mode. So you realistically need to have a way to simulate multiple users in the environment that you are trying to use your access point. And you want to understand how well the access point or base station in a case of a 5G can still maintain the individual streams to individual users, and trying to understand how not only the beam focusing to individual users are working, but also how well the interference cancellation is working when you're trying to isolate the other users from interfering your communication channel. So it really is more a true so-called end-to-end performance measurement system where the access point is really tested against simulated users in the environment.
So what does ETS do physically to build a test site? A lot of things in the past we could just have, Faraday cages or RF shielded rooms. How do you go about simulating reflection and the spatialness you need to do that multi-user testing?
So the first thing is that we try to build a controlled environment. So the Faraday cage or the shielded environment, shielded enclosure, that provides you a multitude of reflections. So that's not necessarily ideal way of testing a MIMO performance because you really cannot control which directions the reflections are happening to your DUT. There are methods of averaging that out, but really the best way is to build a controlled environment with anechoic absorber that basically reduces any reflection that happens through the walls or from the walls. And what we're doing then in the chamber is we're building a multitude of antennas. Basically, it's a circular antenna array. It can be a two-dimensional, where we only have a horizontal ring of antennas, but they also have elevation simulation, where we have antennas above and below horizon, where we're simulating some reflections coming above the near horizon level. And coming out of that is we have an instrument called channel emulation or channel emulator that basically creates the spatial channel model, and certain pieces of the information on the MIMO stream is basically transmitted through those different antennas. Because in a typical faded environment, certain pieces have certain delays, they have certain type of fading profiles, and what the channel emulator does, it basically cuts it into pieces and it feeds it through those different antennas that we have inside the chamber, and therefore we can mimic a typical user environment, whether it's a macro environment or urban canyon type of environment. We can simulate that and try to understand how well those devices are working on that kind of environment.
So let's see if I can recap this. First, you make the environment where the walls have as little reflection as possible, so you can take that out of the equation. And then you simulate the delay spread that might happen in a real world environment. And that way you can control the delay. So how big does this space need to be in order to pull that off?
So that depends a little bit on the devices that you're planning on testing. So the more antennas you have on the ring, so basically more channels that you're emulating, the larger the antenna separation can be. So typically it's relative to the wavelength that you antenna separation in the devices. So in a typical environment, let's say that we are using for standard handset type of testing. It's 16 by 16 foot enclosure, which is roughly about 10 feet tall, and we have roughly about 2 meter or 6.5 feet path length from the sensors to the center of the test zone. And in there, we can have roughly about 0.7 to 0.8 lambda different or separation between the antennas on the device.
I'm assuming it kind of feels weird inside there because since there's no reflections, there's also no sound.
Correct. Even though it's not really truly an acoustics absorber, which is, obviously something that we do as well, but the RF absorber material works relatively well also for acoustic testing. So funny that you mentioned we've had applications where customers have done both RF and acoustic testing in the same environment as well. And yes, it's a little bit weird at first when you go into there.
Yeah, we're not used to that kind of quiet. Well, our audience here, thank you, by the way, for your explanations. Our audience is people who do Wi-Fi almost exclusively for their career. As we're moving into 5G, there's a lot of ties and links between 5G and Wi-Fi, and there's a lot of stories out there about one's going to kill the other, they're competitors, etc. From your standpoint, could you just give us a quick overview of what is 5G and how does it relate to indoor Wi-Fi?
5G and Wi-Fi technologies, the way, obviously, people have different opinions, but my opinion is that they are not going to be really challenged into one another. To me, they look more like a complementary technologies, where there are things in the 5G that come more into the Wi-Fi domain, traditional Wi-Fi domain. My belief is that the Wi-Fi is still going to be predominantly used for certain applications. The number one reason is that 5G is going to be using, at the moment at least, licensed spectrum where providers have paid for their frequency spectrum, and therefore they are trying to capitalize that as best as they can to make sense of the acquisition of that spectrum, where Wi-Fi technologies are used in unlicensed spectrum, where everybody essentially can utilize that spectrum as long as they adhere to the common ground rules that are established to use that spectrum. And therefore, like a cable providers are still going to be primary providing the internet access to homes, because the 5G technology, even though it has a very, very promising and very good performance that has been thought after, it will still take a long while before you can provide the data throughput that Wi-Fi can already provide in the home environment or industry or office environment. So instead of trying to think them as adversaries, I do think that's a complementary technologies. And actually now there has been more and more studies where 5G and the Wi-Fi technology are trying to work on the layer where you leave in the 5G domain and move into the Wi-Fi domain, so that the handover from different technologies would be smoother. I don't think that the 5G industry sees themselves really trying to take out Wi-Fi, because I believe they understand that there's a place for both of them. And Wi-Fi technology, with the introduction of or formalization of the Wi-Fi 6 coming more prominent later this year, that's going to provide lots more improved performance to users of Wi-Fi.
So the technology of 5G, well, let's just start at the very bottom. Old cellular, even before we had like 1X RTT, and then we went 2G, 3G, 4G LTE. Along the way, they had a variety of frequencies that were way better than what we're using in microwave as far as penetrating buildings and houses and foliage. So I could take my cell phone on a regular cell, LTE, and be inside of an elevator. What percentage of 5G is going to be up in the millimeter range where it's that's entirely different versus down in the lower normal LT kind of range?
That's an excellent question, and that's something that everybody is kind of thinking about at the moment. So 5G is going to be divided in several different frequency bands. So already there are 5G, what we call FR1, or some people call it sub 6 gigahertz, which now most likely it's going to be changed to refer to sub 7 gigahertz, sub 7.5 gigahertz. And then there is a certain frequency band above 24 gigahertz, which is referred as a FR2, which is the millimeter waves. And there is a use case for both of them. Obviously, millimeter waves provide a very intriguing way of handling the 5G data throughput, because there's a lot more spectrum available in millimeter waves, and you can use a lot more spectrum to get the data throughputs that, the gigabits that have been kind of thought when you think about the 5G. But millimeter waves are, everybody who's been in the millimeter wave business know that they are not travel very far. So the problem of using the millimeter waves to build the whole network is that you cannot have a good coverage with millimeter waves. So you still need to have the low frequency, the FR1 sub 6 gigahertz coverage on the 5G as well, so that you can actually make your regular phone calls, so that you can actually have data throughput in the rural areas where the millimeter waves are not going to be deployed in the near future. So there is definitely going to be a need for both of them. The sub 6 gigahertz, that's going to be, nation and global implementation, where you can use your cell phone for making calls and, having your location-based services and things of that nature. But when you're in big cities and big stadiums and where you need to have a lot of data throughput to do your social media or whatever, downloading videos and all that, most of those are going to be handled with the millimeter waves. Yes, there is going to be some millimeter waves implemented in suburban streets and things of that nature, but it's never going to be a full 100% implementation nationwide or globally. And, just to that matter, there was a 3GPP meeting that it's actually ongoing this week. And there was a new study item that was just put forward there that the companies are looking also implementing the 5G in the 7 gigahertz to 24 gigahertz. And they are looking the restrictions, where they can use and what frequency ranges they can implement to use in a 5G. So it's not necessarily just that, sub 6 gigahertz and then millimeter waves. There's a movement in the industry to trying to take as much of the free frequency spectrum and implement wireless communications in those. We don't know, obviously, what frequencies those are, or if there's going to be any frequencies available from the satellite communications on that frequency band, but at least they are looking into that.
So it seems like 5G requires a lot of handoff issues, not just handoff between 5G and Wi-Fi, but intra between FR2, FR1, in the middle of their own handoffs between frequencies. All of those require the client side to have radios that are already tuned and antennas tuned to those specific frequencies. Today, when you buy an iPhone or an Android, you get 3G, 4G, and Wi-Fi and Bluetooth. Are they looking to add either a millimeter or the sub 7 gig additional frequencies onto the handsets?
Absolutely, and that's ongoing already. And without mentioning manufacturers, there already are 5G devices available here in the U.S. There was one device manufacturer who introduced their millimeter wave 5G phone here a few weeks ago, and there was one device in Korea that it's used in the network already with the 3.5 gigahertz frequency availability. And most of these sub 6 gigahertz frequencies, those are basically anchor frequencies where there's a signaling and control happening with the network. Whereas when we're talking about the millimeter wave frequencies, which, by the way, are also going to be in a mass market devices in coming year and years, but those channels and those frequencies are handled what we call the carrier aggregation. So most of the control signal still happens, or controlling that happens still in the sub 6 gigahertz frequencies. And the high frequencies are basically just used to maximizing the data throughput. It doesn't necessarily have any kind of control mechanisms or communication with the base station. The communication happens still on the lower frequencies, and they just use that as a resource to transfer in the mass data when available.
Do you foresee any, today and so far we've been talking about cell carriers doing most of the heavy lifting. Do you foresee 5G entering into the enterprise space? Say a hospital or a stadium would own their own infrastructure rather than relying on it.
That is a very good question, and I do see that as a possibility. I do see that the 5G technologies can be used that way, that, a typical wireless access point manufacturers are building their enterprise system utilizing a 5G based small cells or base stations, so to speak, which are outside of the control of the carriers. I don't know exactly any kind of cases where that would be happening at the moment, but I do see that as a potential. Obviously, there are some limitations because they are using the licensed spectrum. So obviously, that needs to be done in conjunction with a carrier. So I legalistically, I don't know if that's possible. I just see that there are use cases of doing that. So let me take that back a little bit. So obviously they can't use the frequency spectrum if a carrier is using that frequency spectrum that they paid a lot of money. So the only way that that would happen is that a major wireless access point manufacturer purchase a frequency spectrum that they're planning on using for that purposes.
You never know. I've seen weirder things. Here's another prediction for you to see if you see a market for this. What about a customer premise equipment that's millimeter wave on one side, Wi-Fi on the other, and you mount it on the outside of your building so you can pick up all the 5G speed for throughput? But since the millimeter can't get in your house, it will transfer over and put in Wi-Fi in your house.
And that is the use case that I do see, and I believe that there are already in the market. So it has been referred for, last couple of years is the last mile kind of infrastructure, where it has been too expensive to trench and getting a fiber optic or getting a cable into some homes. So they have used the millimeter wave link, and some of those millimeter wave links have been already using the 5G radios, where you're getting the high data throughput from the closest tower, and you basically just focus in the beam to act more like a end unit that with the millimeter waves that is focused to the tower on the next to the street, and then you're transferring that through the window or through a cable to an access point that it's basically handling the whole house connectivity, whether that's going to be in Wi-Fi or whether that's going to be handled with the small 5G small cells. That's something that needs to be still, the industry needs to be deciding on, but I can see cases to doing that with either way.
Well, you're obviously in the midst of this with ETS Lindgren doing testing for a variety of people. Your estimate on when 5G is going to be mainstream? I mean, we've been talking about it for at least a year or more. It's the questions my customers are now asking. When do you think we could say, yep, 5G's here?
Well, 5G is here already. If you believe all the marketing materials and all the advertisement that you see in the TV and the news outlets, so
that's why I ask you. I already hear the marketing stuff.
So they're going to be adding cities here during this year into the 5G network. So I believe one of the carriers here said that they're adding 30 more cities by the end of the 2019 here. But that's not necessarily a mainstream at that point yet. So I do believe that the handset and the user equipment that average users are going to be buying later on this year, they're going to have 5G radios on them already. Whether or not they're going to be able to connect to a 5G base station or 5G network, that remains to be seen. I don't believe that in main parts of the world or main parts of the United States, that's not going to be the case. But at least the devices are going to have connectivity once the network is going to be ready. And typically the network, not providers, but companies who manufacture network equipment and base stations, they are typically a little bit ahead of the curve, and they've had their base station and infrastructure ready for 5G for a little bit already. And now we're just seeing that the handsets are catching up with them. And the problem here is that it's a lot easier to get the penetration into the market with the handset, because you can just sell, thousands and millions of them, where base stations, it's going to be a little bit more complicated to have a full country full of new 5G base station. I know that there are base stations that are basically built with provision to go on a 5G immediately when that technology is available. So it's basically just a firmware update that, hey, we're changing our 4G network to a 5G network. And that may be one of the ways to do that, but it still needs to basically be built from ground up with the new base stations and so forth.
So if I was a carrier today and I had a 4G network, it's up, I've got 98% of the country covered. If I wanted to upgrade to 5G, does that mean each tower needs, and I'm just trying to restate what you just said. If I have a 4G network and I want to go to 5G, I'm going to have to put new hardware in. Is that a replacement, or is it an additional, like a 5G greenfield? As in, do I upgrade what's in place, or do I augment it with a 5G, and can 4G and 5G run simultaneously?
4G and 5G can absolutely run simultaneously. So it's not going to happen overnight that the 4G network is going to become obsolete. And in fact, there is going to be a lot more improvements done to the 4G network over the next decade or so. So there are still certain parts of the country where we are using 2G, 3G technologies to handle in the phone calls. So those are still up and running. Yes, we are finally getting rid of them and replacing them with something more efficient, but it has happened over the years. And same is going to happen with the 4G and 5G network. So there's going to be 4G and 5G running simultaneously. So, getting the 5G data throughput, but still having the backup if something does not work as expected, or you have a millimeter wave base station and you cannot get the data connectivity, you still have the 4G network to fall back to, so that you are not without phone call coverage or phone coverage and data coverage. Looking forward, it's going to be basically adding the 5G hardware into the base station, and then removing the 4G network. But all the new towers that are all going to be built, they're going to have these base stations that are upgradable from 4G to 5G without changing the hardware, but doing software or firmware upgrades for the sub 6 gigahertz. All the new millimeter wave towers, there's no way of doing that. So those are all new hardware, and they need to be built ground up.
Can I add a 5G base station onto a 4G tower, and I need additional antenna space as well?
And that is one of the interesting topics. And talking about the 5G space and talking about having small cells and densifying the network. Problem with the densifying the 5G network is that you're going to need a lot more tower space. And municipalities that are dealing with these issues, they need to kind of have rules where the base station can be placed, and there needs to be obviously a leasing fees that are paid for cities, and that is not regulated by federal law, and that's basically handled by state level, and those fees are not equal throughout the country. So there are still a lot of, discussions happening how to handle those. So building a network somewhere in California and San Francisco, it's a lot more expensive than building a network in Dallas, because here in Texas, for example, we have a state legislation that has approved what is a reasonable yearly leasing fee for a cell tower site. But in some of the other areas, that's not the case yet. So there's still a lot of, arm twisting happening on that level.
Sounds good. If you were, obviously you've been there for many, many years, decade plus. If you wanted to get into the 5G world and learn about it, where would you recommend someone go to start a base knowledge of what is 5G? It's in our future. We can't get away from it. So how would one go about learning about it?
Well, the easiest way probably here in the near term is that, there's a lot of exhibitions where different people are showing what they're doing in the 5G world. Mobile World Congress just happened a month ago or so in Barcelona. There's one happening in Los Angeles area, the Mobile World Congress in Americas in later this year. One of the bigger events here, and actually it's called the Big 5G event, that happens in Denver here in May 6th through May 8th, where a lot of the industry people are getting together and talking about how they see the industry developing and what are the new things that they are working, and kind of trying to solve a lot of the problems that are still present of how to implement the 5G globally. Not mentioning just the USA, but globally, because you need to have so many different radios, for example, in the devices to have a really truly a global roaming, and not just focusing on localized problems. So those were good ways to start getting to know 5G, and obviously there is a lot of webinars, and we have in our website we have some information on 5G, and websites are full of information at the 5G.
Well, I sure appreciate your time today, Jari. How would someone contact you or ETS Lindgren?
The easiest way to contact ETS Lindgren would be to go to our website, www.ets-lindgren.com, and all the contact information there for our local offices, where, whether we are here in the North America or Europe and Asia, they are posted in there, and with that way you could have a contact on your region's office that you listen into this podcast.
Well, Jari, thanks for your time today. I hope you have a great weekend, and we'll talk to you soon.
Thank you. You too.
Thank you for joining us for another episode of the Wireless LAN Professionals Podcast, the podcast for wireless LAN professionals by wireless LAN professionals. Be sure to follow us on Twitter @WirelessLANPros for all the latest news and updates, and also connect directly with Keith on Twitter @KeithRParsons. Head over to www.wlanpros.com for this episode's show notes, as well as the latest in all things Wi-Fi.